This is a project a student sent me that they had a question on. So I was going to look at it first part of class. And if I run this, so I select main class. They put a 3 in here, click add, 4, add. So just our standard. What they're wondering is when I put a 5, how do I program an enter? And what the enter would do is it would automatically put it in the list. Well, I didn't know, so I did some research myself, and found this video. So we're going to try to incorporate this. And actually, let me check to see if that's already in there. So I haven't looked at the actual code. I was looking to see how to do it first. Key press, maybe a key press is where it'd be, but let me look at the source here. See what's in here. Button, add mouse click, clear list, mouse click, remove mouse click, calculate mouse click. Those all look like ones that are okay. Add key released. And that kind of looks like what I was seeing in the video. Key released. Okay, before we look at the video, events, key released. And here then, I probably just called their code just so I can easily find it again. Okay. Button add key released. Actually, let me just copy this code into here. Yeah. Can you hear me? There it goes. Oh, you lost video. Yes. It's been a week of issues. Okay. Okay, now it's working. Well, that was easy. um, but that's how you would put an enter in. So what I did, and they explained the code. So if you want to start using that on your own, you'll know what it does. Is first off, I have to right click here and choose events. There it is, events, and I went down to key and key released. Now the difference in all these, key pressed is when you're holding the key down. So you push it down for the first time, that's pressed. When you let up, that's released. When you just type, um, that's just a general catch-all for it. So the release is the best one because that's when you let up on the key. Now, if you want to program them holding down the key, then you can program that. But I put a code under that. And his code was just your standard set your model up here. And then this is checking the key code. This is based upon our event. Specifically, the event here is you press the key. And the EVT can be whatever you want to call it. That's you can think of it as a variable, but not exactly. But that's our designation for that. And dot get key code, that actually gets whatever key code was pressed. And this key event dot vk enter, This is probably tied to some kind of number. If I had to guess, let's see, TF underscore num dot set text and key event dot VK enter. What is VK enter? Key event dot. It is not gonna. There it goes. Okay, it looks like an integer. I figured that's what it was, but I wanted to check, make sure. Now here, I don't know. I need to do a string dot value of, mixing languages up again. I think. Yeah, value of. There we go. Now if I run this, I want to indicate what is it really checking for. And I'm just guessing. I never have looked this up, but it's a pretty educated guess. Okay, so do a 3, and then I press enter. I put 10 in there. Well, let's see. Wish I could remember the website, ASCIItable.com. You see 10 over here in decimal is a new line, line feed, new line. That's why I said I was pretty sure that it was integer, because I was figuring it was tying to the ASCII character here. Probably, if I go back to my program, and just in general, not having an if statement, but just print out the get key code. So if I say tf num.set text string.value of event dot get key code, like that. Now let's run this. Now this will happen anytime you press a key. It'll put the value of there. Okay, so I'm in this. I press my space bar and let up. Puts 32 in there. You see 32 is a space bar. If I press the number 1 and let up, it should put 49. And it does. So if you're trying to capture, if they push one of these characters, that's how you can do it. I said it was a pretty educated guess that that's what this was, because I don't know of any other way you would program it, because everything's based upon ASCII table and programming things like this. So you could program the escape. If they press the escape, you could do something. What's escape? Escape is 27. I used to have some of these memorized, but as I've gotten older, I don't remember. So if event dot get key code is equal to 27. So you can put 27 in there. And let me move this in here. And I want to say why escape. Okay, so this is going to do this up here if it's an enter. This will do it if it's an escape. Okay, so I'm in here and I type escape. You see it came back and said why escape. So you could program something. If they hit escape, maybe the escape would clear out the blank. Now, that's kind of hard to remember. It's not that hard to look it up on the table. So they've tried to make it a little bit more user friendly. These key events dot VK whatever. I'm assuming VK stands for virtual key. This is a mapping. So they map these to these numbers. If I can find out where this is stored at, then I can see all those. So instead of you having to memorize 27, you type key event dot VK, and somewhere in this you'll see probably underscore escape. I had to guess. Escape spelled out. So this is one we want. Does that make sense on the what those key events are? Okay. Probably if I right click on it, and there might be some way to navigate to that, or go to source, go to declaration. Let's go to source. Well, let me do that. Okay. Show Java doc. Key event. Insert. Anyway, you get the idea. But somewhere, navigate to declaration. It's not gonna let me go there. Okay, I'm gonna go ahead and close that. And let me bring up the book. Helps if I got my flash drive. I'll be right back. I didn't bring my flash drive. As always, if you have trouble with your programs, email me. I'll work on the first part of class. It helps for other people to see how to debug the problem. Okay. Strings and things. Strings and things. Chapter 9. Here, see if I have a project I can work with. Okay, that one should work. Java and other object-oriented languages. Object is a collection of data that provides a set of methods. For example, scanner has different methods for him getting input. System.out and system.in are also objects. Strings are objects also. String is declared this way. String fruit is equal to banana. And then we can retrieve one character by doing the string name dot character at and then a position. Okay, so come over here and drop on a new text field. There it is. I'm going to have a button. Actually, I'm going to put another text field on there. That's curious. Thought I dropped that one on there. Oh, repositions up there. I didn't want it up there. Okay, and button. So I'm going to right click in this JText field 1, do an edit text, backspace, enter, resize it. And do a view. No, editors. No. By the way, you can do a view and choose editors. And see, there's also source and history you can choose here. I'm probably looking right at it, but I don't see a zoom. Let's try to make this bigger so you can see it better at home. How in the world can you not have a zoom button? Go to my best friend. Where is zoom in NetBeans? Alt scroll wheel. I was doing shift, I was doing control. I wasn't doing that. Alt. Okay. You lie. It's not scrolling or not zooming. Oh, that's NetBeans code. NetBeans editor. Font size, go to tools, go to change font size. Okay. And the zoom in a NetBeans code. I don't want code. Text, editor zoom. This plugin adds the action zoom in, zoom out to the menu bar. Well, I don't want to do a plug-in. Maybe there's no way to do it without the plug-in. Oh well. Hopefully you can see this okay. I'll right-click on this, change variable name. I'll call it TF string. And right-click on this one, edit text, do backspace, enter, resize it. Right-click on it, choose change variable name, TF, answer string. Right-click on my button, edit text, run, whatever I'm doing. Right-click and choose events. And mouse, there it is, and mouse clicked. Okay, so I'm going to have a string. This will be my input, whatever I get. And then I'll have an output also. Those are probably bad because they're probably reserved words. Input S for input string and output S for output string. Input S is going to equal to TF underscore string dot get text. So I'm going to do something with input, and then I'm going to write it out. So TF underscore string or TF underscore answer string dot set text inputs. Okay, so we're ready to start looking at a bunch of different functions. The first one they present in the book, and there's a ton of different things you can do with it. And strings is very important. If you can master this, you're going to be able to work with files. So if somebody sends you a file of data, you'll be able to parse it apart easily. If somebody has some input that they put in on a text field and you want to parse it apart, you can do it. If you want to check to see if it's in a proper format, assuming you're not using one of the formatted text fields, then you can do it. So it just gives you total control on checking and parsing part information. Okay, so I'm gonna type in. I'll use banana. What they did. Now we talked about arrays. We said arrays start at position 0. Strings are arrays of characters, so they also start at position 0. So this would be position 0, 1, 2, 3, 4, 5. So if I want to get the character, you see it's actually a char. That's different than a string. Uses less memory, and we do the name of it dot character at 0. So if I declare a character, one char, I'll call it. Then to retrieve the B in banana, I'm going to say one char is going to equal to input S, that's our input, dot character at 0. Okay, now we want to convert that to a string. So this part I'm not sure how to do. We'll see. Maybe string dot value of. I can spell. Oh, I did. You know, an interesting. I was talking with our IT person yesterday. He was over there, and I just wanted to say hi to him because I don't hardly see him. He's at the main campus, and I was telling him about how I was having so much trouble yesterday, and I finally restarted and I fixed it. But I hadn't restarted for quite a while. I usually just shut the lid on my laptop and just so I can easily get up and running. And he said that he read something or he heard something, and then he went out on Microsoft's website and read it, and he was shocked to hear it. When in Windows 10, when you do a shutdown and then you restart your computer, you push your button and so forth, it does not actually do a reset, so it doesn't release all the memory. When you do a shutdown, it stores off all of your memory locations that are being used. So then, when you push that button and you think you're coming back on, then it hasn't freed up anything. He said restart is what you actually got to do. So I thought that was interesting because I always figured shutdown powered it down completely, and then when you turned the button back on, it came up and all the memory was released and all the issues you might have had are cleared up. So if you are going in IT and be working with a Windows 10 machine, that's an important thing to remember. Um, it makes you wonder, but yeah, that's and he said what Microsoft said on their site might have been a design flaw, but what they said on their site is they wanted it to come up fast. So when people do a shutdown and they turn their computer back on, they wanted it to come up fast for them. A restart will take longer. You'll see it go through a little so forth, and that's because it truly is releasing all the memory and setting everything back to like the default. Yesterday, with all my troubles I was having, if I had just done a shutdown and then turned my button back on, it wouldn't have fixed anything, and I would have been sitting there scratching my head, wondering why am I still having these troubles. Okay, now string.value of converts anything to a string. So, and one char was fine. So let's run this, and then we're gonna write a piece of code that's gonna maybe check to see if that's not in class, how many like A's we have in our word. I think I can do it with characters. I definitely can do it with something a little bit later on in the chapter. I never have done it with characters, so we'll try that. Okay, so come down here, type in banana, and you click run, and you see it returns B because that's position 0. If I type something else like Sally, position 0 would be S. Now, part of dealing with characters is, and sometimes some programming languages make it easy, some don't, is a character is like a single letter, but it can also be an escape. It can be all of these. So sometimes in programming, you have to make the appropriate conversion to one of these other types, depending on the language. We'll see if this does it though. Okay, so I'm going to have let's see, count equals 0. That will loop through for int x equals 0, banana starting at 0. And I'm going to continue, and I could hard code in, less than 5. I can hard code in 5. And that nothing wrong with that, except for actually I got 6 characters. um, so I'd want to do 6. X is less than 6, and that would work. But then what if they entered in a string that was bigger than 6 characters? Well, instead of doing that, I can do X is less than, and length should be either a method or probably a method if I had to guess of a string. So if I put in input s dot, and I'm looking for length or size length. Okay, so it says returns the length of this string, and then x plus plus. So now it is no longer hard coded um, for length. I can put any in there. Now I'm going to check here if this is the part I don't know. This is the part I'm questioning. I'm going to do input S, and I'm going to get character at and X. That'd be fine. Uh, and let's do an equals equals. And I'm going to do a single quote. Some programming language, a single quote is how you do it. And it didn't squawk, so that's good. And then I'll increase count by 1. And then down here, I'm going to count. Okay, so this looping here is going to go through it character by character. So go to position 0, position 1, 2, 3, 4, 5 for banana. And if that character at that position is equal to A, then it'll add it. So when I'm done with banana, there should be 3, if it works. Let's try it. Put banana in here. Up to 3. A dog ran fast yesterday at the park. So we got 1A there, 2 A's, 3, 4, 5, 6. And comes up 6 A's. Now you can, if I knew how to do it, you can check it against the actual code. So you could come over here and check to see if they put any of these invisible characters in there. And you say, what do you mean by invisible characters? Well, there's sometimes where you can put a invisible character in there, and then it messes things up because you can't see it. But from a programming standpoint, it's screwing with your program. But I don't remember how to check that. I think it's see A. What's A? A is right over here. Okay, lowercase a. Oh, lowercase a is different than uppercase a, so keep that in mind. Lowercase a is 97. Let's see if I can check this against 97. Then run this. Okay, so if I put banana in here, see if it still works. Banana, 1, 2, 3, and it gives me 3. Now you might be saying, whoa, wait a minute. You just were comparing a character like A, B, C to 97. Well, from a programming standpoint, when you deal with characters, they're kind of interchangeable with the decimal equivalent over here in the ASCII table. So I could check to see if they did a carriage return. You could check any of these, and they're treated as characters. Over in Word. Dear mother, everything is going well here at Camp Granada. Okay, so we got some text here. There's this little paragraph mark right here. If you do the paragraph mark, this shows at least some of the invisible characters. I don't know if it shows all of them. This is a paragraph mark. I don't know what a paragraph mark is. I think it's this. I think it's one of these. It's either 10 or 13. I don't think it's 10. I think it's 13. On the other hand, if I'm right here and I do a shift enter, it's really hard to see, but there's a character there. I wonder if there's any way to see the number on it. Probably not. Let's see if I could do a Control C on that, and then do a replace or find. See how there's more here. I'm just looking to see if there's anything special. Okay, looking for a paragraph character. Okay, it still doesn't show us what number, but Control V. But these are invisible characters that are in your Word document. So you may receive input in a file that has some kind of weird invisible character in there. And those are sometimes the hardest problems to discover. Because here saying you can't see it, but it's messing up your program. Oftentimes you debug it and see what the value is to so forth. But they'll emphasize this as you go on to more programming classes. You'll get used to the ASCII table. There's a reason why there's a website just dedicated to the ASCII tables because it's so widely used. Anyway, enough about character at. Is there any questions on the character at? Yeah, it takes a little bit. And really, where I've had to use this ASCII table a lot is when working with specialized printers. Because if you're trying to work with a specialized printer, especially over here in Word, let me shut the paragraph mark back off. This is my first line, and here's a paragraph mark, and that's my second line. Here's my first line. Here's a shift enter, and that's my second line. You notice something about it? There's less space when I did shift enter. So if you're trying to create a label on a specialized printer, and it's like not fitting on labels, you got too much space there or something like that, that's where you manipulate some of these. If you're wanting to do a horizontal tab to go over to someplace a little further over on the label, then you send this code. So you write these codes out to the label. I think that's some programming I hated the worst, was sending those special codes to printers. Okay, we talked about that. I guess you can check escape sequences directly, like /t, which works on some of them, but /t is a horizontal tab. So if we go with the way I showed you, horizontal tab, just saw it. Here's vertical tab, here's horizontal tab. You check it against 9. Problem with using the slashes here, the escape sequences, is because that doesn't cover all the possible possibilities that they have for a character. Now notice, here we got a 4 character, C is equal to big A, going to big Z, C++. And you said, whoa, here you're adding 1 to it? What in the world's that doing? Well, when we say going from big A That's actually going from number 65 because big A is 65. Going to big Z, uppercase, big Z is 90. So this is actually looping from 65 to 90. And that's why it's acceptable to do a plus plus, is because the character is interchangeable with the number in our ASCII table. Okay. That's a why you can do it. The book doesn't really talk about it. They just say you can do it. The increment and decrement operators work with characters. And that would display the letters of the alphabet if you did this. Java uses Unicode to represent characters, so strings can store text in other alphabets like Cyrillic, if I'm saying that right, in Greek. You can learn more about it at unicode.org. Unicode version 4. ASCII was very simplistic, and so it was extended because you couldn't do all those weird characters or different characters that are over in other languages. Little Grav, they do. If I'm even saying it right, it's been a long time since I've had Spanish and French and so forth. You can't print a dingbat with ASCII. So the question is, can I print this star on my screen? 2,730. Can't be just as easy as just putting that in there. I never have tried to print this, so we'll see. Okay, so I got a character. Say character is equal to, character. One character is equal to, no memory, 2730. 2730. Okay, so convert that to a string and write it out. Let's see if that prints a star. If it doesn't, I won't waste any more time on that. I was just curious. Okay, I guess I really don't need anything in here, but let me put something. And didn't print a star, so not as easy as I think there. Okay. Example is a typecast, convert each integer. Strings are immutable. Strings provide methods to uppercase and to lowercase that convert from uppercase to lowercase and back. These methods are often a source of confusion because it sounds like they modify strings. But neither of these methods nor any others can change a string because strings are immutable. So what this does is you have to reassign it to a different string or back to the same string. Now the two uppercase and two lowercase changes to uppercase and lowercase. First time I wrote a database program, I allowed the user to input the state. And they would put Kansas in. Some people would put KS, like this. Some people would put little k, little s, like this. Some people would put big K, little s, like that. You might say, well, what's the difference? They're both KS. Well, if you go to your ASCII table, there is a big difference. Big A, 65, is different than little a, which is 97. Which means I had reports that had Kansas in like 5 different groupings, and the sales or whatever I was reporting on for each one, which was an issue. So how do you get around that? Well, if they're going to put state in, you could do a list box, a combo box, like we had indicated before, If you're going to put it in a free cell like this, you'd want to check it against a table, but maybe you want to change everything to uppercase. So, let me see, get rid of this. Input S is what's come in. And so I can say input S is equal to input S dot, what was it, 2 uppercase? Yeah, 2 uppercase, like that. So what that'll do is it'll act on this object here. It'll take it, and it'll convert everything to uppercase, and then it'll reassign it back to input S. Immutable means you cannot have something like this. That does not change input S. So this is going to return a string, which you then need to assign back to something else. You can do it to a different variable, or you can put it back into the same one. So now if I run this, and they come in and say big K, little s, and you click run, it changes them both to uppercase. Well, if you're wondering, how do they do that code-wise? It's kind of beyond what they're really talking about here. But if you notice that all of your A through Z is goes up to 90, doesn't it? If you check the individual character and saw that the individual character was greater than or equal to 97, well, maybe you check to see if it's between 97 and 122. If it is, it's lowercase. Now, there's a difference between these. The difference between 97, my lowercase a, and 65, my uppercase a. 97 minus 65 is 32, which means if I take this and subtract 32 from it, that'll change my lowercase to an uppercase. So again, manipulating this number does have some advantages. Now I said the range because if you come down here, this is a curly brace. If I subtract 32 from that, I'm assuming it gives us this one straight over here, since everything else did. But it would give us this, which is not. It changed a curly brace to a bracket. Here it changes pipe symbol to a slash and so forth. So only makes sense for numbers. But that's how they're doing it programming wise, in case you're wondering. But they made it real easy for you. They simply said 2 uppercase. Now, if you want to convert to 2 lowercase, well, just put, oops, so I can spell, 2 lowercase. And now we convert it all to lowercase. String traversal. Actually, I looked at that already. Remember, we went from 0 to our index less than fruit.length. And fruit is our string. And then do I++. Now, I counted how many A's there were, but they're doing a little bit different. There's another way to do a string traversal, too. Here's the enhanced for loop, which I didn't cover in the last section because I wanted to wait till we got to here. This is how you can loop through it character by character. For character letter, and letter can be whatever you want to call it. And then fruit, that's your string name. And then dot 2 character array. So what that gets done, when it gets done running, fruit dot 2 character array, here's our string, banana. So that's our string. When you do that 2 character array, what it's doing is this putting this into an array of characters? This is the position 0, 1, 2, 3, 4, and 5. And so that's what that 2-character array is doing. And in the process, then, it's looping through each character in that array. So it looped through B-A-N-A-N-A without having to directly access the indexing that we've used in the past. So it's kind of a short way to go through an array of characters. Excuse me. Find the last letter of a string. You might be tempted to try something like this, root.length. But remember that it's one, our array goes to one less than the length. It goes from 0 up to the length minus 1. Oh, this is where it says length minus 1. Here's how you can go in reverse. So let's see if we can write a program that'll take a string and print it out in reverse order, without looking at that. And close that. Okay, so we want to reverse the order of it. Okay, so let me think. We need a new string because we're using the have I even used output s? Okay, I'll use output s here. Output s is equal to an empty string there. I'm going to loop through for int x equals length, not length, input s length minus 1. Continue while x is greater than negative 1 and x minus minus. Okay, banana. 0, 1, 2, 3, 4, 5. And the length of banana is 6. Now, strings always take me a little bit. I had to wrap my mind around them. I do a simple example like this just to think what it should be. Now, I want to go in reverse. So I want to start at A, go to N, go to A, go to N, go to A, and go to B. That's my goal. Okay, so I'm saying I'm starting at X equals input dot length. Length is 6 minus 1. So that would imply I'm starting at position 5 for this example. And that works. Okay, so then I keep going while x is greater than or equal to negative 1. So I still want it to work when x is 0. So the next one would be negative 1, which would be too far. Okay, so that looks good. Now the concatenation, I'm not sure how this is going to work, but we'll see. Outputs is equal to outputs plus, and then I want to take inputs dot character at, and I might have to convert this to a string. You hate that at first, how it keeps popping up all over the place and kind of throws you and so forth. You're eventually going to learn to love it, unless you have a fantastic memory. Who in the world can remember it should be a capital A? Although you will see a pattern on these. Okay, get rid of that lowercase. And then we'll print out output S. Okay, so again, that should start at position 5, which is right here, and concatenate onto my output string. And then it decreases the x minus minus, so it should go to position 4, the in. You can concatenate that on. Oh, I didn't click it. Did I click it that time? Try it again. I'll probably have 5 versions running here soon. There we go. And something didn't work right. Oh, there. Banana spelled backwards. So that's how you can reverse order those. Um, Gosh, what is pig Latin? Um, Get rid of the first letter, and I know there's a bunch of rules for it. But you get rid of the first letter, so dog becomes og day. I think that's right. Get rid of the first letter, put the letter on at the end, and then put an A on there. Is that right? Does anybody know pig Latin? Okay, let's assume that's correct. So let's think about how to do that. That'd be an ananabe. Okay, so I want my new string. For int, now output s is I have as a blank. Int x equals 1. Continue while x is less than input s dot length. What in the world? And x plus plus. If I don't need those since I got a single line of code. Actually, I'll leave that there. What in the world am I doing? Well, I'm starting at position 1. Position 1 means I'm ignoring that first character. So I'm going to anana. So I got output s is equal to output s plus the input s dot character at x. Now, when that gets done, it should say anana. Then, on output s, outside of the for loop, I want to concatenate on the first character. So input s character at 0. That'll put the b on at the end. And then output s is equal to output s plus a. And that should convert to pig Latin. I encourage you to play with these at home. Recreate these projects that I'm doing here and really examine what it's doing string wise. Because if you wrap your mind around these examples, and you're going to find working with strings is a lot easier, no matter what programming language you go into. These are all the same. This same bit of code you see me do here is the same bit of code you do in C#, the same bit of code you do in Visual Basic. Some of them are a little bit different, like C and C++, but still the same principle. Okay, banana. Banana bay. Dog. Og day. There's other rules for Pig Latin. Um, I would search for it, but I'd probably bring up something inappropriate. 'Cause I don't. So I'm not gonna. I'm not gonna search for it. But the idea of Pig Latin is that you change the word slightly like that, and nobody knows what you're talking about. But usually everybody does. They usually do jokes on television shows or movies about somebody speaking Pig Latin and they don't understand a word what they're saying. And there's other rules along with it. Like it starts with a like a vowel. Um, you have to do a certain, not a vowel. Boy, it's been so long since I've had English. That's bad. Yeah, vowel. Vowel is I E A and all those, right? I've forgotten every bit of my English. No, no, vowel is what in the world am I thinking of? Those of you who have had English, what's A E I O U and Y sometimes? Vowel sounds. Hmm. Okay. Guess I haven't forgot everything from English. Verb. Verb is what I'm thinking about for like the action. Okay. But if you have it is does not become say I a. So I don't remember how you do that. I don't think it'll bring up anything appropriate. Um, Pig Latin rules. Move the constant cluster from the start of the word to the end of the word. When words begin on a vowel, simply add yay. Okay. So we can even change our program then. My semicolon. If it's a vowel, I want to do it differently. So I can check. Um, if the first letter, so input f dot character at 0, and maybe I better assign that to a variable because we haven't talked about somebody searching. So one character, I guess. One character is equal to input s dot character at 0. Then we're checking if one character is equal to a, or one character is equal to e, or one character is equal to I. I know there's more than that, but I'm going to stop there. Then you simply add on yay, Y-A-Y. Which one do you do? Maybe it doesn't matter. Is way, is yay, is a, is a. I'll add on AY. So then, um, input or output S is going to equal to output or input S So I'll take the entire string and I'll add on a on the end. Now, if it's not a vowel, I think that's called a constant. Okay. So let's run this. So if I type in is a. If I type in dog, should be og day. I screwed that up. I lost my AY. Okay, I knew I'd messed something up over here. Plus a. Anyway, I won't run that again. You get the idea. Sometimes programming books put that as a project because it helps you understand more about strings and how to work with them. Now, I'm ready for substrings, and I don't want to go into that today because there's quite a bit we can do with substrings. And our first programming project out of this I'm going to assign is going to be based on substrings. So we'll go ahead and stop there. There won't be any project out of today.